it's used in so many different ways because so many things are right triangles. If you go look at a light pole, the light pole is making a right angle with the ground. So that's a right triangle. So if we know two of its sides, we can always figure out the third one. Now, let's talk about figuring out the unknown side of a right triangle. What is this side right here? We'll call it y. Do you know how to figure it out?
Okay, so you do 15 squared plus y squared equals 20 squared.
Good. Okay. Now what?
Okay, hold on 1 second.
Yeah, you should probably have your calculator handy.
And 15 squared is 225. And then plus y squared equals 400.
Okay. So now what?
So now you're going to subtract 225 on both sides.
Okay, so we have y squared equals 175.
And then you can do the square root of 175.
And again, that's a number that's better left like that, or actually a simplified version of this.
Okay.
Now, do you know how to simplify that? Do you know how to reduce that?
Well, it says it's 13.228.
Okay.
But I think he wants us to leave it as the square root of 175.
This is called the radical answer. If you were to do this, what'd you say it was? 13.78?
13.22.
If you were to give this as an answer, you're giving an approximation. You're not giving the exact answer. So this is the better answer. There's only one problem with that answer. It's not simplified. It needs to be simplified. It's like giving this as an answer instead of that. You never want to give an unsimplified answer. So let's talk about how we simplify this. There's a rule in algebra that says if you take the square root of the product of two numbers, it's the same as taking the square root of one times the square root of the other. Okay?
Okay.
So we're going to use this principle to simplify the square root of 175. Now, what we're looking for is two numbers that multiply to 175, one of which is a perfect square number. Tell me what your perfect square numbers is. I'm going to list them over here on the right. Starting with 2 squared.
Okay, so 2 squared, 4.
3 squared.
9.
4 squared.
16.
5 squared.
25.
6 squared.
36.
7 squared. We'll go up to 7.
49.
Okay. So I could keep going. But the idea is we're now looking for factors of 175, one of which would be one of these numbers over here. Do you recognize one of those numbers that might divide into 175 evenly?
Let's see.
And how many times would it divide into it? 25. First of all, if you see a 5 as the last digit, you're looking to divide that by something that has a 5 in it, usually. Okay? If you're looking for a factor of it. Well, use your calculator. How many times does 25 go into 175?
7.
Okay. Which means I can write this as the square root of 25 times the square root of 7, right?
Yeah.
Based on that rule above it. Well, Well, this is useful because this is a perfect integer, 5. So that's simplified. That's what the square root of 175 equals, is 5 root 7.
Okay.
Okay? So up here, the answer for y would not be this. It would be 5 root 7. And if you got the decimal of that, it'll give you the same decimal as the other. So it's the same number, it's just simplified.
Okay.
So this list of perfect square numbers is really a good list to kind of know. This 4, 9, 16, because you're going to be doing that a lot. Maybe not so much with geometry, but with algebra you'll be doing a ton of it. So knowing how to simplify these is really useful. Okay, so figuring out the unknown leg of the figure.
Okay, so that's going to be 5 root 7.
Yeah. Hold on a moment. Yeah. Oh, I see what's going on. Huh. No, I don't. This triangle always gets me. I always want to make this a 12, 15, 20 because 4 or 5 goes in. Yeah, see that. I always want to make it a 3, 4, 5 triangle. But the 3, 4, 5 triangle has the 20 as the other side. And then it's 25, like that. In other words, that's the same as a multiple of a 3, 4, 5 triangle. And this one is easy to confuse with that. So this one is 5 root 7. And what's the total area of the entire outside shape?
Okay, so would it be 75 root 7?
Well, what's the area of a triangle? What's the general formula?
Oh, divided by 2. Okay, so it's A equals base times height divided by 2.
You know, that's a fine way to remember it, but you usually see it written like this. In other words, the first word is half. Area is 1/2 base times height. At least that's the way I always refer to it. And that way you don't forget the 2. Because when you remember it as base times height divided by 2, it's easy to forget that very final part. Whereas if you start out with 1/2, there's no way you're forgetting it. You know what I'm saying?
Yeah.
Okay, so the area is what? 1/2 the base
15.
times the height. So again, that's a complicated number. What is that? I mean, again, let's not convert it to 5 times 15 is 75 divided by the 1/2, 2, and then we still have the root 7. So that's a perfectly legitimate answer, and that is as simplified as that gets.
Okay.
Okay? Now, you could put the decimal answer. He'll probably accept either one, or did he specify specifically that it needed to be in radical form?
He did not say.
Okay. You might want to determine that. I mean, you can't go wrong with this answer.
Okay.
Okay? That is the precise answer. So where's the question? Is there another question below this that says what's the area of the shaded region?
It says, what is the exact shaded area? And your answer should involve subtraction.
Okay, so what is it?
So, let's see here. So it would be 75 root 7 divided by 2 minus 9 pi.
Very good. That's the answer you want. If you were taking an ACT test, this is the answer they're going to show. They're not going to show the decimal answer. And you leave it like that. Believe it or not, that's as simplified as, that's the proper way to show that answer, right like that.
Okay.
It's the only exact way. Any other way would be an approximation. Okay, so let's look at 12. Do you have this in front of you so I don't need to worry about you being able to read it?
Yeah, I have it in front of me.
Okay. So they don't like to mix things up, do they? What's the, oh no, I'm sorry. What's the radius of the small circle?
It's 9 pi again. Okay, sorry, that'd be 3.
No, that was my fault. I probably set you up for that one because I thought they were asking the same exact thing again also. Radius is 3. What's the radius of the big circle?
That would be 6. No. Oh, okay, so it'd be 8.
Okay. What is the exact area of the unshaded region?
Okay, so...
In other words, the area of the white area.
So it'd be 64 pi.
Hold on. What's the area of the
unshaded?
Mm-hmm.
That would be 9 pi.
Right. Same as before. What is the area of the total area of the entire outside? The big
64
circle.
pi.
And therefore the area of the shaded region is...
Let me see. 55
pi.
pi.
Don't forget the pi. The only reason we can do that, in other words, the only reason we can subtract is because it's like terms.
Okay.
As long as this is an apple and that's an apple, then we have 64 apples minus 9 apples. But you end up with 55 apples. Okay, is there, there's no, oh, there I can get to the bottom. Oh, you know what? I wasn't able to do that before. Oh, we got all kinds of questions over there I didn't see.
Yeah.
Oh, boy, something strange is going on with my picture here. All right, as long as we're on this one, let's finish up this one, and then we'll go back and pick up the stuff I didn't see the first time through.
Okay.
So we've answered E, right?
Yes.
So F, what is the probability that a random point on the figure is from the shaded region? Answer as an exact fraction.
So you would do 55 pi over 64 pi.
Correct?
And then equals x over 100.
Well, no, an exact fraction. In other words, don't give it as a decimal. Answer as an exact fraction. Well, what happens? What's 55 pi divided by 64 pi? What can I do with the pi's?
Cancel them out.
Okay. So now we have 55/64, and the only thing we have to determine is whether that's simplified. Is there any number that divides into both of those numbers?
No, there is not.
No, the factors of 55 are 5 times 11, and both of those are prime. Because both of those are prime, it means there aren't any other factors that are going to be 55. And since neither of those numbers divides into 64, that's an easy way to check as to whether something is simplified or not. So that's your probability, is 55 over 64. And then to the nearest whole percentage, what is the probability that a random point is from the shaded region? This time she wants the answer not as a fraction, but as a percentage, which we're going to get by starting with a decimal. Yeah. So first of all, what do we have?
So we have 55 divided by 64. And that's going to be 0.859.
How many places does she want that out to? Is it always 3?
It says...
to the nearest whole percentage. Okay, what percent does that equal to?
85%.
Well, you'd round it up, right?
Okay, so 86.
So 86%. All right. Now let's go back and look at the first question again. Did you write your answers for these? So you can just kind of...
Yeah, I did.
Okay, good. So we're on D. What's the probability that the random point on the figure is from the shaded region? And let's see, what did we have for an answer on this? We had 400 minus 9 pi, correct?
Yes.
So there was the area of the shaded region. So what's the fraction?
Let's see.
What goes
9.
That's the shaded region. I got to divide it by what?
9 pi. Or no, the total area.
Total area, 400. Okay. Now, can I do anything with that? I don't know whether your teacher wants your answer to look like this. She definitely specified an exact fraction, but I can break this down into two numbers. I can break it down into that. Well, 400 over 400 would be 1 minus 9 pi over 400. So maybe she wants that answer, or maybe she wants this one up here. I'm not sure. Probably she would accept either one, is my guess.
Okay.
And then, the numerator of your fraction should have a greatest common factor, which may factor out. Rewrite your answer to D, but with the numerator factored. Now, I don't see anything that factors out of the numerator. Am I missing something?
I don't believe so.
The only factors of 9 are 9 and 1 and 3. And none of those numbers divide into 400. So the only way, that's kind of bizarre that she would put that in there. Shaded region is 400 minus 9 pi. And all these questions have to do with the shaded region. So 400 minus 9 pi is the numerator. Well, I don't know what she means by E, but reduce and simplify as much as possible. Well, we kind of did, unless she means this. You might want to put this as your answer to F. I would leave this as your answer to D. Same thing on E, and reduce and simplify as much as possible. Presumably she means that. I don't know.
Okay.
I would write that just because it's the only thing we can really do here. And then to the nearest whole percentage, what's the probability means you need to convert this to a decimal, round it to 2 figures, and put it as a percentage. You can do it in your calculator either way, either doing it this way or doing it this way.
Okay. That's gonna, oh, no, that is not right.
Notice probability always has to be between 0 and 100%. There's no such thing as giving 110% of your effort.
Okay.
You know, did you hear the athletes all say? That they give 110%, that's impossible. The most you can possibly give is 100%.
Okay, let's see. So that I came up with 0.929.
Okay, so that rounds up to 0.93, which is 93%. And does that make sense looking at this figure? Actually, it seems a little high, but I'm sure that that's correct. Wow.
Okay.
No, it seems very high. They must not have drawn this to scale. No, they didn't.
Yeah.
Notice that the 6 centimeters covers way more area than it should.
Yeah.
If this is 25 centimeters, this would indicate you could only fit maybe 2.5 of these circles in the 25, but in reality you could fit 4 of them. So this is not drawn to scale at all. And
yeah, none of the stuff is drawn to scale.
Okay. So we can't really eyeball it to check whether we're in the ballpark. But so we got to trust our math. But that's fine. Our math is good. So where'd we leave off here? We got the area, the exact shaded area. So what's the probability that a random point giving the exact fraction? Yeah, this was a strange one too, wasn't it? So what was the shaded area?
That was, let's see. Oh, okay, so it was 75 root 7. Oh, divided by 2 minus 9 pi.
Okay. So that's the shaded area, and we're going to divide that whole thing by what?
2,
by this. Right? In other words, we want the shaded area divided by the outside figure.
Oh, okay, so it would be out of 75 root 7 divided by 2.
Okay. Now, here's where, let's see. Can we pull anything common out of that? I don't think so. 9 doesn't go into 75. But 3 does. So we can factor out something in the numerator. You can factor a 3.
All right.
Now, first of all, it's useful to know that a number is divisible by 3 if you add it up. This becomes 12, 7 and 5, and 12 is divisible by 3. That makes this number divisible by 3. A number is divisible by 9 if it adds up to a number 9. In other words, I know that 81 is divisible by 9 because it adds up to 9. I know that 108 is divisible by 9 because 1 and 8 adds 9.
Okay.
Okay, so those are some useful rules. So let's see, I've written this so huge I don't even have room to. Okay, so what are we going to factor out and how's it going to look?
Okay, so it would be 3.
Now something's going to be left over. In other words, what we're going to do is divide both of these terms in the numerator by 3.
Okay, so
what do you have left over here?
25 root 7 divided by 2 minus 9, or 3 pi.
Okay. And that's all we can pull out. We can't do anything else. Can we pull a 3 out from the bottom?
Yes, we can.
Yeah.
Or no.
That'll be useful because now we can write the bottom as 25 root 7 over 2. And immediately this 3 can now cancel with that 3. So that is somewhat helpful. So what do we got now? We got 25 root 7 over 2 minus 3 pi in the numerator. Well, if I want to manipulate these into one thing, I'm going to multiply this by 2 over 2 to give it a common denominator of 2, In other words, 3 pi is the same as 6 pi over 2, right?
Yeah.
And now I can write the numerator as 25 root 7 minus 6 pi all over 2. We're going to divide all of that by this denominator, which is 25 root 7 over 2. And now we do this by doing what? How do we accomplish that division?
So the 25 root 7 divided by 2, wouldn't the 25 root 7 cancel itself out?
No, the 25 root 7 does not. Well, it depends on how I want to end up doing this. Once again, the only thing I know for sure is that the 2's will cancel themselves out. In other words, the way we divide by a fraction is we reciprocate it, we flip it, and multiply, right?
Okay.
So the 2's go away, and I'm essentially left with that over that. 25 root 7 minus 6 pi all over 25 root 7. Now, you could give that answer if you want, or we can do the same thing we did earlier, separate it into 2 fractions. There's the first fraction, that's the number 1. What's the second fraction?
6 pi
Over 25 root 7.
Okay.
Now, boy, they introduced all kinds of problems with these questions. What is wrong with this answer? There is something wrong with it.
Okay, well, let's see.
You cannot have an irrational number in the denominator. If I'm going to give a fractional answer, I have to rationalize the denominator. Let's talk about what that means. If I have an answer like this, how do I rationalize that?
I don't know.
We can multiply it by the number 1 without changing its value. That's the number 1, root 2 over root 2. What do I get? I get root 2 over 2. That is the legitimate answer. It's the same number if you put it in your calculator, but that is not considered mathematically sound. I don't know if it's because the mathematicians all just decided that they would never allow an irrational number in the denominator, but you don't want to give this as an answer ever. And our answer suffers from that. It's got this root 7 in the denominator. So how can we fix that? Well, I can't change the value of that fraction, but I can multiply it by 1. So what's the 1 that I'm going to multiply it by?
The one outside.
Root 7 over root 7. Why root 7? Because now it's going to get rid of the square root sign in the denominator. It's going to put 1 in the numerator, but that's perfectly fine.
Okay.
What is root 7 times root 7?
It's 1.
7.
Oh, so
It's always whatever's in the middle. Root 13 times root 13 is 13. If it was divided, in other words, this is 1. But in order, the next step in this process is to go ahead and multiply tops and bottoms. So I get 1 minus 6 pi root 7 in the numerator, and in the denominator I get 25 times 7, or 175.
okay.
So there is one answer for one of those questions. And then, of course, you can turn that into a decimal. Go ahead and turn that into a decimal. We know we need that.
So it's going to be 0.715. So it'd be 72%.
Okay. And as far as the answer, hold on, as far as this answer for F, answer as an exact fraction, I would say that answer should be what I have circled right here. I would think that's what they want.
Okay.
If not that, then this one that I have circled. And in fact, you might want to put the top one down for F, and oh boy. See, this one did have a greatest common factor. So they might have wanted you to put down this 75 root 7 over 2 minus 9 pi all divided by that. And then after we factored out the 3, you'd put down the 25 root 7. You see what I'm saying?
Yeah.
In other words, G applies to this problem. G did not apply to the first problem. There was no greatest common factor. This one actually had it. So it's possible you might want to put down this for F, put down this for G, and put down 72% for H.
Okay.
Is that the last one, H?
Yeah.
Okay. So now we've done this whole page, right?
Yeah.
Okay, let's go on. Boy, it's kind of strange to me that these answers were so screwy. In other words, involving that irrational number, involving that irrational number, and then wanting you to list it as ratios. All right, let's open up what next? Photo 50, the next one you sent me?
Yeah.
And let's see. Is there just this one problem here?
Let's see. Yes, I believe that was the only one yeah.
Okay, so let's see if I got this straight. Did you get this right, or?
Yeah, I got that one.
You got that one right? Do we need to
Yeah.
not go over that?
Well, it is correct. I just,
Let's go over it. Sounds like
Yeah.
you're not 100% sure how to do it. Okay, so always start these geometry problems with your general formula. Area equals 1/2 base times height. Well, they give us the area, so I can fill in that for area. What else do they give us?
let's see.
Which measurement do they give us, the base or the height? They want the height and the perimeter, so they must have given us the base. What is the base of this triangle?
It's 21.
All right, so that's 21 there. And the only variable in that equation is height, which means we can solve for it. So help me solve that equation. Finally an equation that's not root 7s and pi's. And
Alright, so first, you could divide by 21 on both sides, right?
that's actually the best first step. Why? Because 21 divides evenly into 84. 4 times.
Yeah.
So now I got this. Now what?
And then now you are going to multiply by 2 on both sides, right? Because you have a half.
So that's how we solve for H. That's how we got 8
Okay.
here. Okay? Now, to get the perimeter, we need to solve for that side and this side. Let's take a look at this triangle here. This is 6, 8. What's this side here?
That would be, okay, so to find that side, you would do 6 squared plus 8 squared equals c squared.
Okay. Go ahead and do that.
Okay. And then you do the square root of 100, and that's 10.
Okay. Now, that was the hard way to do it. Why? Because there are two triangles that you always want to look for. You're just going to run into them 100 times, I guarantee a minimum, over the next 3 years. One is the 3, 4, 5 right triangle. And another is the 5, 12, 13 right triangle. Those are the first two Pythagorean triangles. By the first two, I mean the smallest two. You won't find one that has smaller whole numbers than these.
Okay.
And when I say look for this triangle, I mean look for this or multiples of this. Well, a 6, 8, 10 is double a 3, 4, 5. So if we notice that we're looking at, this is twice a 3, 4, 5, this has to be twice 5 or 10 without even doing the math.
Yeah.
Same thing, this triangle here is the third next Pythagorean triangle. If you wanted to memorize 3 of them, these are the 3 you'd want to memorize right here. So that when you spot them, you don't have to do that math. And in this case, we would have spotted that also. It's 8, 15, this has to be 17. So look for these triangles or multiples. In other words, if I said, okay, let me give you an example. I got a triangle here, this side's 30, this side's 40, what's this side?
That would be 50.
50. In other words, it's this, whatever the multiple of that to that has to be the same ratio of that to that.
Okay.
Whatever that similarity ratio is. Do you use that expression in your class, similarity ratio?
Yes.
When comparing triangles?
Yeah.
Yeah, okay. That's what makes, in other words, if you find two triangles that are similar, and that was a perfect case where one was 3, 4, 5, and the other was 30, we'll use the 6, 8, 10. These triangles are similar, and their similarity ratio is 2 to 1. That's just their linear ratio. That's not their area ratio. The area of this triangle is actually 4 times that. Notice the area of this triangle is 24, and the area of this triangle is 6.
Okay.
When you go from linear to area, you square that ratio. The ratio that started out as a linear ratio of 2 to 1, when we want the area ratio, we square it, and we get 4 to 1. An important concept. You may not have learned this yet, but it's coming. So once we've labeled this whole thing, now the perimeter is quite easy. What's the perimeter going to be?
The perimeter is, let me see here.
Yeah, not a number so much as what am I going to do to get it?
Oh, you're going to add up all the sides.
Not the 8.
Not the 8. The 10, the 17, and the 21.
6 plus 15 plus 17 plus 10. Okay. Let's see. Do I have any other problems on this page?
No, that was it.
Okay. So let me open up the Okay, so this is solved for the unknown sides or the unknown quantity?
Yes. So I got some of them, but I couldn't figure out what other of them were.
Okay.
So I couldn't find J, R, and I, and N.
Okay, some of them may need others answered before you can answer them. Let's have a look. J. Well, J is 15 minus H and I, right?
Mm-hmm.
Well, you solved for H by knowing that area was 12, so that had to be 4. Well, what does I have to be?
5.
Okay. So now, go ahead and draw on your paper 5, so that I don't have to redraw this whole thing.
Oh, and to find J, you would get 15 minus 9.
Correct. So that's 6. Now label it. Okay, now that you know J, you should be able to get... Oh, no, not yet. Hold on. You know what? I may have to label. I may have to draw this just so that I can keep it straight. All right. 4, 5, 6, 15, 3, 6. What's the area that's going to be?
That's gonna be 54.
And we know the area of that, so what is this dimension here?
That's 4.
Yeah, looks like you solved for that. And this is 4, and this is 9, so the area of this is what?
54.
Is that everything?
I believe so.
Okay.
Oh, N. N is going to be the same as J, so it's 6.
Yeah.
6.
Yeah. I presume that Q is the area of this region. Is that what this is?
Yeah, that's what I think. I think so.
Well, or else it's this length.
Oh, yeah, I found the length for that, and then I got 6.
Okay. In other words, when they want area, they actually ask for it down here, area of 5 and area of 6. So that is Q, which is obviously the same as that. Yeah. Okay. That's all on this page?
Yes.
Is that all we have?
I think that's all we have.
Okay. Do you have any questions you want to ask? It sounds like you understand stuff pretty good.
Let's see here. I think I'm pretty good.
Okay. We don't need to take up a full hour if we run out of material. Although in general, it's better if you send me more material than an hour would cover rather than less.
Okay.
Okay? Just because I'm sure your mom probably wants you to get a full hour of tutoring. But at this point, I wouldn't know where to begin if I, had to make up stuff. So we'll go ahead and end this session at this point. And let's see. Did you talk to your mom as far as do you want to make a permanent one, or do you want to schedule them online, or do you want to go ahead and schedule your next one now?
Let me get her in here really quick, and I will let you know.
Okay.
No. Okay, my mom actually just left right now, but she said probably Mondays and that she would call you to confirm what days.
Do you want me to go ahead and block off next Monday right now?
Sure.
Okay, let me do that because otherwise somebody can go in there and take that spot. So I will do that, and if you end up not wanting that, the sooner you could let me know, the better, and then I can open it up again. But
all right.
Otherwise, if you like, I'll just plan on texting to your phone the meeting ID number. Now, the way you get out of this is to click on the X in the upper right, or if you're looking at that tiny sliver that has the little orange with the white arrow on it, if you click on that arrow, it's a toggle switch. It opens and closes the whole control panel.
Oh, yes.
And then you can log out by just clicking on that X in the upper right.
Oh, okay.
And that's how you get out. But how you get back in for next time is you will see something. See this little go to meeting thing on my desktop here?
Yeah.
You should have that kind of an icon on your desktop now.
Okay.
I don't know if you can see it or not.
Oh, yeah, I can see it.
Okay, so if for next Monday, I will just text you the meeting ID to your phone, and if you double click on that, it'll ask for that ID. We'll be all set. You don't have to re-download the software every time.
Okay.
Okay? You just need a new meeting ID number every time.
Okay.
And I have been recording this. I will send tomorrow, I will send the link to this recording to your mom's email.
Okay.
And you can see how to look at it. I don't send the whole recording to you because it's too big, but I send you a link that lets you watch it on my website if you like.
Okay.
All right?
All right. Thank you.
You're welcome. Talk to you next Monday.
All right. Thank you. Have a nice night.
Bye-bye. You too.